In this video, we will learn how to solve linear inequalities. We have some rules for solving inequalities. We have the additional principle. If A is less than B is true, then A plus C is less than B plus C. So for example, we have 5 is less than 7. If we were to add the same number to both sides, then the inequality will still hold true. 7 is less than 9. We have the multiplication principle. If A is less than B, C is greater than 0 are true, then A times C is less than B times C. So for example, we have 3 is less than 5. And we're going to multiply by a positive number, C. Let's multiply this by 4 and 4. We then end up with 12 on the left side and 20 on the right side. 12 is still less than 20. So the inequality stays the same right there. Now, if A is less than B and C is less than 0, that means C is negative, then A times C is going to be greater than B times C. So notice that the inequality changes. So for example, we have 3 is less than 5. And this time we're going to multiply by a negative 4. Then we end up with negative 4 times 3 is a negative 12. And 5 times a negative 4 is a negative 20. Now notice that negative 12 is bigger than negative 20. So we have to write the inequality this way. So notice that the inequality changes direction. And keep in mind when we're multiplying, it's the same thing as dividing the reciprocal. So when we divide a number, it's the same thing as multiplying by the reciprocal. So this principle still holds true. So anytime when you divide or multiply by a negative number, the inequality sign switches direction. Let's take a look at example 1. Solve the following, then graph the solution set. So first thing that we want to do is we want to simplify each side as much as possible if needed. Looks like they're both simplified already. Next, we decide which side we want the variable to be on. I would prefer to have the variable on the left side, so I will get rid of the variable on the right side by adding the 2x to both sides of the inequality. So remember that when we add, the inequality sign stays the same. 5x minus 5 is less than 6. Then I will get rid of the 5 on the left side by adding. Again, when we add, the inequality sign stays the same. 5x is less than 11. Next, in order to get x by itself, I need to divide by 5. So when I do that, the inequality still stays the same just because I'm dividing by a positive 5. Now graph the solution set. Here is 11 over 5, and there's an open circle at 11 over 5. Less than, that means all the numbers on the left side of 11 over 5. If we were to ask to write this in interval notation, that would be negative infinity, comma 11/5, parentheses. Next, let's take a look at part B. We are solving for the inequality. Again, first thing that I would do here is to get the variable on one side. I'm going to subtract the 10x. Subtracting and adding, we still keep the inequality the same. 13 minus 7x minus 10, that's a minus 17x. And then on the right side, we have a negative 4. Next, subtract 13, inequality sign stays the same. Negative 17x, it's greater than or equal to negative 17. Next, I want to get rid of the negative 17 by doing the opposite of multiplying, dividing by negative 17. Remember that when we divide by a negative, the inequality changes direction. So we have x is less than or equal to negative divided by negative is a positive 1. To graph this, we place a close point on number 1 because of the equal, and then all the numbers that are less than 1 are on the left side of 1. If we were to write this in interval notation, that would be negative infinity to 1 bracket.